All right, Intro to Cal and Statistics, here we go. This is lesson 8.2 continued. 8.2 we've been talking about arithmetic sequences, and today we're going to continue by talking about finite ones. So here's your formula. Make sure you get it down in your notebooks. The sum of a finite arithmetic sequence with n terms is given by s sub n, which equals n divided by 2, times a sub 1 plus a sub n. So let's just go ahead and define all of those things. S would be your sum, and n is the number of terms that sum is going to have. This is a great way to label our problems. So n is the number of terms, so if we have 50 terms, 50 is going to be your n. A sub 1, you remember, is your first term, and a sub n will be your last term. So you're going to go ahead and add the last term and the first term together and multiply by n over 2. So here's an example. It's already done out for us. So here's our formula up at the top. We want to find the sum of 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus 17 plus 19. Now obviously if you have a calculator it's not that hard to do, but what if you type a number in wrong? Or you can add it all out on paper. Again, not that difficult, but you could make a quick mistake. So we can use this formula to ensure that we get it right every time. So we have 10 terms, count them up, 10. So we're going to have the sum of 10 terms, S sub 10. N is the number of terms. So we have 10 terms. So that's 10 divided by 2, which gives us 5. And then our first term is 1, highlighted in green, and our last term is 19, highlighted in yellow. So add those together and get 20. So 5 times 20 is 100. So if you were to add up all 10 of those numbers, the sum would be 100. All right, so you'll try this for homework tonight. Don't worry, the video is not over yet. Let me just clean this up a little. Is to find out the sum of these numbers. So you got to figure out how many terms there are and what's your first and last term. So make sure you try this for homework tonight. All right, the last part of the notes for tonight is the sum of an infinite arithmetic sequence. So this is when there is no end. It just keeps going on and on forever. So you could be asked to find the sum of the first 200 terms. You could be asked to find the sum of the first 400 terms. It just keeps on going. But it's silly to write all 400 terms out. So we can use this process to help us figure out the sum of the nth terms. So this problem in red says find the 150th partial sum of the arithmetic sequence 5, 16, 27, 38, 49, ... So there are a couple of key words here that you want to remember or make note of. Partial sum. This isn't going to be the sum of the entire sequence. It's just part of it because it goes on through infinity. The next thing is the arithmetic sequence. That means that we have a common difference between all of these values. And that's really important because we can't do this process without that common difference. So if you remember back to the beginning of the section, you were given this formula. A sub n equals a sub 1 plus d, that common difference, times the number of terms minus 1. So we're going to use that to help us figure out what our 150th term is. Obviously, you could write these all out, but that's going to take way too much time. So if we look for our 150th term, you take your first term, your a sub 1, which is 5. You look for the common difference, which is 11. Remember, you get that 16 minus 5 or 27 minus 16. You'll get 11 every time. And then it's just n minus 1. So you get minus 149. So go ahead, take a quick second, see if you can figure out what the 150th term is. Did you get 1,644? Excellent job. That's right. So our 150th term is 1,644, and I just wrote our first term here again so we could see it. Now we can figure out the partial sum of this sequence. So we're looking for the sum of our 150 terms. So n is 150 divided by 2. You take your first term and add it to your last term, which in this case is a sub 150, and you get this amazing number right here, right? It's kind of fun. 123,675. All right, so that's it. No try this problems at the end of the video. We're going to work on bookwork tomorrow in class.